This is an Interpro video describing the failure analysis for RMA 11-0090. The board we're going to be testing today is an FCRO VF6100, serial number 48478. The reported failure for this board is no indication of phase loss when one phase is missing. For our test setup, we have our board sitting on our SCR fixture, which is set up as a rectifier. For our controls, we have our pot here to control our sig high that's feeding to J3. We also have two toggle switches on J3, one for the instant inhibit enable and for the soft instant enable. To power the board, we're going to be using the lab power supply, which will generate our 24 volts DC, which will feed into pins 1 and 2 of J3. For our monitoring devices, we have our oscilloscope here. Channel 1 will monitor the phase loss signal, which is located on U6 pin 1. Channel 2 is monitoring TP7, which is the output, the gate pulse from the LSI. We have 2 meters here, which monitor the line voltage and line frequency. The line voltage is generated through a motor generator set, which is located outside of our facility. We are controlling the motor, which will set the line frequency with this inverter, which is powered on to a 480 volt source. Our line is also connected to these breakers here, which will allow us to cut one or more phases during the test. Alright, to begin the test, we're going to monitor the 3 LEDs. You can see all 3 LEDs are on as I power on the board. You can see that all 3 LEDs turn on. First LED is for phase loss. Second LED is for inhibit. Third LED is for power on. You can see on our oscilloscope, our phase loss signal is still low, which will indicate a phase loss, and we have no output from our LSI. I'm going to go ahead and begin the test and initialize the motor generator set. As you can see, as I started the motor generator set, once it detected the phase, the LED did turn off, and our phase loss signal went from low to high to indicate phases are good. Inhibit light is still on because the board is inhibited. That's why we don't have any gate pulses. As I enable the board, you can see that the LED does turn off, and we do have our gate pulses, and our phase loss signal is still high. Okay, I'm going to go ahead and cut one of the phases, phase B. As I cut phase B, you can see that both LEDs turn on for phase loss and inhibit. Our phase loss signal went from high to low to indicate a phase loss, and we have no output from our LSI. As I bring it back in, both LED comes on. Our signal goes from low to high to indicate phases are good, and we do have an output from our gate pulses. I'll go repeat the test for phase B. Okay, phase C. Now I'm going to do a combination of A and B. And B and C. Now you can see from our test that if we lose one or more phases, the LED does turn on, and also the inhibit signal. Our phase loss signal goes from low to high once the phases come in, and from high to low when the phases are cut, and our pulses do extinguish when phase loss is detected. This will conclude our video.